Good afternoon to everyone. Uh, my name is Sivaji, Associate Professor, Department of Information Technology, Institute of Aeronautical. The subject name is Compiler Design. So today we are going to take the first module concepts, that is Introduction to Compilers, and what is a compiler and what is an interpreter, and then the differences between compiler and interpreter, various phases of a compiler. That means how the program is to be converted from your given language into the corresponding machine language. And here there will be several number of phases. That is total 6 phases are to be developed. So lexical analysis is the first phase of the compilation. So what is the role of lexical analyzer? And then input buffering, token recognition. That means in the process of defining the output in the lexical analysis, what are the tokens that is generated, how it can be recognized by the compiler. That is the notation to represent finite automata notations and regular expressions, and then how the conversion between expression to an automata, and then passes and phases of compilation. That means sequence of steps it can go through the compilation. Meanwhile, that is number of times the compilation goes for an entire program. How many number of times? That is depends upon number of phases, the number of passes. So depend based on that we can justify that there is a single pass compiler or a multi-pass compiler, and then bootstrapping mechanism, and then Lex Analyzer Generator. It is a program this the outcome, that is the topic which we choose, that is introduction to compilers, that is compilers and interpreter differences, learning outcome. See here, what are the language processing system that is to be implemented now to convert the given program source language into a machine level language. That is here the compiler takes place an important role for conversion of this generation of the. See, first initially we will see the definition of a compiler. What is a compiler? Here compiler means it is a process which translates the given programming language in one language, that is source language, and convert into another language. Compiler which takes the source program and then generate the corresponding target language, that is mission prod target program, which is then mission. So here what is meant by source language? The program generally the developers, that means whoever the programs are written by the users, those who are developing the code, client program, they are going to write the programs in terms of several languages such as C, C++, Java, several PHP, Perl, Python, several other languages are to be developed, and they are going to write the programming language, and they are going to write this source program with several lines of code. All the statements which are in high-level language statements. High-level language are that the language statement depends upon the corresponding syntax and semantic of the program. Suppose if it is a C program, we are going to write --include std.h, and if it is C++, header files followed by coutc, and if it is Java program, the corresponding header files followed by the printf system.out.println, void system.out.println in case of Java language, whereas in the C++ we are going to use the main method. Like that, the different programming language with the constructors are to be defined. And this programming language, what are the programming language? Here computer, it is nothing but hardware and software. Hardware means the peripherals which are connected, like for example scanner, printer, keyboard, all this comes under as hardware parts, whereas the software comes under the programs which is written by the user. For example, here the software is once again divided into two parts. That is application software and system software. Application software and system software. These two categories comes under software. See, application software where the programs are written by the user. User writing by user writing programs uh, by usage of several language notation, that is C language or different programming language notation. Whereas system software is a software which makes use of system to do the tasks of the computer. For example, MS Word and Windows, several Paint. These are the programs that are already built in. That the program is written and makes use of this to run the particular system environment. So that is called as system software, and this is called as application software. So here the main important one is here what are the language programs you have written. That can be maybe high level language, low level, middle level language, several language notations with the examples of that is C, C++, Java, etc., Python. All these languages have to be can't be understood by the machine. So here the machine understands only the corresponding specific binary code only. Machine understand binary code. So what are the programs that is written by the user? What are the programs that is written by the user? That is in the programming languages, programming language notation. That is. So we have to one of the translator is required. One of the translator is required in order to do this task. That means what are the programming language written by this one can be converted into translated into this one. So compiler. So in order to understand this machine language understandable machine code, the corresponding compiler has to be introduced so that it works as a translator. What are the program that is written by the user, that is source program. Source program can be whatever the program that is written by the user can be easily converted into your target program. So machine understandable code is required in order to do the task. Machine understandable code is required. So compiler is a translator which translate your given programming language. That means source language, compiler, and then target language. Here, target language notation, which is easily understood by the machine, whereas source language, which is understood by the user or programmer who is writing the program. That means user. That means what are the developers which are writing the program. That statement, programmed statement, can be easily understand by the user. So he can easily write the programs, but machine can't understand the corresponding target language. Users can't write the programs directly in terms of machine code. So in place of that's why compiler is required now to do the task of the compiler translating your given source program into a target language. So equivalent target program is so here the compiler takes place an important role. Why? Because the source language statements are to be easily converted with the help of several phases. Compiler also do with the help of several number of phases and given easily translatable. We will see that how the phases are to be developed and what are the tasks. Each phase having separate input and output of the working mechanism. So that it can carry out the task and then further the processing of every phase is to be simplified. So here in order to do easier the task, here previously what are the programs have to develop, that one can be easily coded into the corresponding machine's language. So machine gives the output, easily gives the corresponding output. So here what are the programmer is expecting the output that is to be executed and compiled, executed, and then machine generates the corresponding output. Why? Because the target language that is generated by the compiler can easily recognized. It can easily recognized by that one, so that machine gives them. So machine can't understand the programming language, what are the written language. So user can't write the target program machine code, binary code directly. So in order to perform the both the things working properly, that means user is familiar to write the several languages in place of C, C++, Java, whereas machine understand only binary code. So in order to play the smooth role between the two cases, so here the compiler has been introduced, and this is to be working out with the phases, that is several phases. We'll see the shortly what is the different phases which are to be occurred in the case of compilation process. So this is the definition of a compiler. It is a simple definition. The given source language to converting into another object language. That means object language is required by because machine understand that object language. Here target language is required by because machine understand this language and gives the output and gives the corresponding results to the user. What are the programs written by the user? Here programming language written by the user is source language. This language is in the form of C, C++, Java, etc. These programming languages are then converted into the corresponding output, which is the machine understandable language. Coming to the next compilation, one of the important point. So here there is a link between your application development and the what are the programs that is written, and then it is before going to execution, the compilation takes place, and it is a main important part of the software where the application is deployed before getting the results. So it plays an important role in the real-time application software development life cycle also to produce the software enhancement or software requirement productions. It is the give the main view, abstract view of this abstract development, and then application which executes on several machines. So another part of this one is whenever the program is executed from source to target program. Here we already know that the programs are to be written in source programs for various languages, and then target object code that is to be understandable by the computer machine. Here machine understand this, machine generates the corresponding language where user or developer programmer who is going to write these languages. So while conversion, any type of messages, errors are also displayed while conversion. So sometimes the errors are of different types. So syntax, semantic errors, runtime errors, like that there will be several number of errors may take place. So all these tabs are also to be displayed properly while conversing from the source program to your target program. So it is one of the important point where errors are also shown, and then once again the compilation process stopped. Why? Because if there is any errors are there, it is compilation stopped and given to the user once again with the corresponding messages, so that user once again the verified with the corresponding errors, and then the release of that is a removal of errors takes place once the program is rectified, and then once again it is going to the compilation process. So this compilation process is to be done several times until compilation, until all the errors are to be eliminated. So if the errors are eliminated, and this we consider success. Compilation is success. Then whenever compilation success, then only we can see the output of the program. So before if errors are not removed, then there is no chance of going for execution phase. So part of the execution phase means output can't be displayed to the user. So it placing an important role to check the verifying the errors process also, so that the user can identify that yes, this is a so and so thing happening, and then overcome the corresponding errors, and then after success compilation, then the user can see the better results, that is output of the corresponding program. That is one of the important phase of the compilation process. where user can see these errors before the source program to target. So while execution this program that is the source converted into a source language to our object program, the source program must be compiled. It is compiled. I told you that before that also. The compilation is an important phase where the conversion takes place from source program to object phase and errors are to be rectified. And then after that it is loaded into the memory. That means at compilation stage it stays in the hard disk only. That means it can't be loaded into the memory. That means here the compilation takes place and execution, the program execution, the success state at that time, that is stayed in the hard disk only. That is after compilation success without errors. No, that means there is no errors in the program. Then the next phase, that is go for execution. So if the errors are not occurred, then we can expect that some output is to be displayed. If errors are occurred, then once again we have to eliminate the errors and then come to the compilation phase once again. Once again, the compilation process starts. Once again, the compilation process starts until errors are to be error to be rectified. Until error to be rectified, then we can say that is the process that is. So here two steps, one to convert, that is two parts of this execution of the program takes place. And once the program is written in any high level language such as C, C++, Java, first the source program is to be compiled with to convert into a target program without errors. So any errors are there in the previous slide we have seen, the errors are to be displayed, and then user once again rectify that one. After that, the execution of the program takes place. That is second part is execution. So once the execution is completed, then that means it is program is loaded into the memory. Until that, it doesn't go to that part of it. That means the users are also verify that where the error line number, corresponding column number is to be shown to the user, depending on the compiler which is to be used for that operating system. Then that is to be notified. Then execution success of the errors. There is no errors, zero errors. Execution takes place. Then we told that there is one more, that is the interpreter. Compiler is one and interpreter is another one. Here the terms are closely related. Why? Because it is also doing the task of the same as compiler, but we are going to see the differences, how the interpreter works. How the interpreter works. That means here it takes the source program as well as input data at a time. Both this two cases, and then takes both the things and then giving the result output to the user. So here both the phases, that means translation, execution at a time. At a time it will do the thing. Whereas in the compilation it doesn't do. Here compilation is error rectification is one time, and second one is execution is another. So checking the syntax and semantics are to be separated in case of compilation process, whereas here it is not separated. So that's why both are task is same. That means the result is what are the outputs which is generated by the compilation. Interpreter is also getting the results, same results, but the difference here we are going to see the start of the differences, how the compilation and interpretation takes place. Source program and input, that means what are the input. For example, we are going to, for example, a plus b, addition of two numbers, that means 10 plus 20. So the input that is to be given while program running itself, the input is supplied by the user, and then the addition 30 is to be output result, output 30 is to be displayed to the user at a time. Whereas here in the case of compilation, we are going to give a notation, that is a compilation process, a separate input wise, and then predicting the output as so result here. Compilation what 30 is getting the result. Here also in case of interpretation we are going to get the same result. So how the translation execution phases are separated, what is the differences, we'll see that notation. For example, here what is the input that is to be taken as a compilation process? Here compiler, the whole program, that means what are the, for example, A.C program taken, which contains several lines of code, that is 1, 2, 3, 4, so like that 10 statements may be available. That means here it is considered as a whole program, these 10 statements to be considered as one program. This is entire program. At a time, this whole program is to be taken as input to convert into the corresponding machine code, that is target program. Whereas here interpreter side, if we take the whole instead of taking this entire program, the line by line, step by step execution of the instruction takes place here. So first line number 1, after processing this step 1, then moves to the second step, and then third step, and then fourth line of statement go for. So at a time, instead of going at a time all the statements, here step by step manner execution takes place in case of interpreter. So that is the main difference while for taking. And another one is here generation of the code, that is what are the code, that is for example while converting from source program to target program, that is mission code, which is mission understandable code. The file that is generated, that is or AOA.exe file here, for example in case of C language, but we didn't see this file, but internally the C drive, if you are executing any program, then internally it generates an intermediate file. This file is called as intermediate file. This file is called as intermediate file. That means here, for example, in case of, if you observe in case of Java language, so your first .java program you are executing. So the file, that is this .class file, first .class file is to be generated. So this file can't be seen, you can see the file in the corresponding folder which is available in the drive, and this is to be created while translating your source program into your corresponding object program. So in this way, whenever if you use the compiler, it generates some of the intermediate codes. This is called as intermediate files. Whereas in case of you observe this one, it does not produce any of the intermediate code. That means this .exe files or .class files doesn't create, but the execution takes place as a step-by-step manner, and this, and the results are to be available. Results are to be available and shown to the user. The process of compilation is which is different from the process of interpretation notation in input versus output. So here the 2 points. First point is whole program at a time is going for execution, and then the execution give the result to the user. Whereas in case of interpreter, instead of taking the entire program, it takes the corresponding line by line and step by step sequence of the statements to go for execution. That is the first line, and this is the first statement, and output is the second one. That is what are the .exe files, .opj files, .class files that is to be generated as part of the compiler, whereas the type of files does not occur, it cannot be generated in case of interpreter. And now one more other difference is how it can be internally the process of working takes place in case of compiler and interpreter is here. We already discussed about that compilation process is done first. That means any errors are to be notified, so that is shown to the user. Once the errors are success, then the execution is to be taken place. So here the corresponding language automatically object code is that is to be generated. Whereas here in case of interpreter, the compilation and execution can be done simultaneously. Here the important point is, here it comes a compilation done one phase and execution is done as a part, separate 2 parts. But here there is no separate part, it can be done simultaneously at a time. at a time, both compilation and that means, suppose for example here, suppose there are 10 statements are there, for example 1 2 3 4 5 like that, five statements which are available in this programming language. What are the program which is written by the user? The internally it takes as a some while condition, and first statement it will analyze the corresponding, and report the errors are also reported at the same time. At the same time, execution also takes place. So analyze and execute, both the statements can be bundled inside a loop mechanism. All trial statements while true, the corresponding list of 1 2 3 4 5 statements are to be available inside the loop. Each step one is to be carried out with analyzation and then execution, and then completion of the just second statement, next third statement, until all the statements are completed. Then this while loop exits. Then that means the process of execution. That means the program statements are completed. Then results are to be displayed. So here the important point is, here the compilation goes the phased manner only. That phased manner with that is source to target program, two separate parts, compilation execution. That means the whole program at a time going, it shown the error shown the user and then giving the results. Whereas here in this case, analyzation of step one, execution at a time. Similarly, second step, like that, all the statements to be done simultaneously at the same time. They are not separated in this case. That is one of the important difference. Another one is if you come to the memory case. So here the requirement takes more memory. Why? Because compiler takes more memory. The code that is generated, intermediate code is to be generated. Some of the intermediate, that means I told you that previous slide, the .class files, .exe files, .obj. Because of these files, some of the memory takes more compared to the interpreter. Whereas here, in case of interpreter, it doesn't create any of the intermediate files. So comparatively, compiler interpreter takes very less memory. So that's compared to the interpreter. Compiler takes more one compared to the interpreter. Interpreter takes less memory. Whereas optimization, so at a time, whole code, whole program, it is going for compilation and then execution. So entire code we are going to send, that is translating. So here we have to implement some optimization. So this optimization is as a module 5. We are going to discuss with several techniques and methods which are available in the optimization phase. So it is one of the important phase of the compiler. That is the last phase of the compilation process. That is sixth phase of the compilation process. So here that means if you use the optimized methods, then the code becomes simpler, so that we can get the results fastly. That means whatever the program which is written by the user can be optimized. If it is optimized, the code is optimized, automatically the program runs faster and gives the better results. So that's why here the compiler point optimization plays an important role. Whereas here it line by line execution, interpreter side line by line execution, but interpreters are optimization is available, but not that much techniques are available as that of the compiler part. Interpreter has his own optimizations are there, but compared to this interpreter, good optimization techniques are there in case of compilation procedures. So that is one of the important. One is memory requirement takes heavier for compilation and less for interpreter, whereas optimization is available in case of compiler, not that much available, but it is still robust as part of that compilation. So another one is here main difference if you compare it with the interpreter. So here a lot of compilation as well as execution takes place. So before execution, compilation need to go. That's why some overhead takes place. It takes definitely more time compared to the interpreter. Whereas interpreted at a time, step by step, all the statements are to be executed. So that's why it is slower. Whereas here, some of the things are to be done previously. So compile time overhead is to be completed. So that's why it takes faster compared to the interpreter. But interpreter, what happens? You have to do analyze the statement, executing the statement for step 1, step 2 at a time. So that's why it takes some slower compared to the compiler. And compiler takes that time for compilation process. Previously, it is completed with the errors, so execution faster compared to this interpreter. Whereas error comes to here, rectifying the errors are to be difficult. Why? Because here the line number or column number which is given by the user, once again going to the corresponding line number, column number. But the way of showing the errors of the compiler to compiler, C compiler and Java compiler is different from different to another one. So there's somewhat difficult compared to the interpreter, whereas interpreter is easier. That means the way of showing the errors, it can be easily understood by the user, and then he can easily rectify the corresponding what it is, and then he can. But here the way of understanding or getting the going to that particular line number, and then so compared to the interpreter, it will be difficult. And programming languages which are to be supported, that is examples or different examples of compiler are Fortran, COBOL, C, C++, Java, etc. All these comes under compiler, whereas examples of interpreter are PHP, Perl, Python, Java, JVM, virtual machines, etc. Some of the programming languages which are to be used that is for interpreter part, and giving the better results. Already proven compilation and execution for case of compiler, and direct execution, direct is step by step here in case of interpreter. Most popular language Python nowadays, they are going to be interpreted language it is, and getting the very good results fastly compared to this compiler. And like that, previously executed programs C++, Java also getting the with good success compilation rates, and then getting the results are to be shown to the user also. So these are the examples of various languages that is following this compilation process, compiler, and the languages which are shown that is as part of interpreter. So one of the language that is used, that is Java language, which we all know. Here in case of Java language, we are the program, whatever the program that is written by the user, which is in the high level, that is Java language, converted into the machine understandable language. So it is called as hybrid approach. Why? Because here the compilation and the execution, it uses, that is compiler and then interpreter also. So compiler and then interpreter, it uses both the thing. That's why it is called as an hybrid approach. And why? Because here internally Java virtual machine, we already know Java virtual machine language as part of Java. So in order to run our Java program, the software that is required is called as Java Development Kit, JDK. The software that is required is Java Development. So it contains the software where Java virtual machine takes place a major role. That whatever the program that is written by the user, .java program, can be converted into the corresponding object code. Before converting, it releases this file called as .class file. It releases a file called as .class file. This .class file can be go for execution, and then by using interpreter, it executes the corresponding program. That means here internally Java C is the command. Here C stands for compiler. And the compilation takes place, the corresponding Java program, or release of the .class file. And then internally the native code that is to be developed. JIT compiler is one internally just-in-time JIT compiler. JIT means just-in-time compiler. This just-in-time compiler is to be part of the Java virtual machine. It is a part of Java virtual machine. So it do the mechanism, that is the compilation and the interpretation of the .class file into the machine understandable. It compiles the corresponding .class file and then understand the corresponding generating of the object code flow. So Java, two commands are there, C drive Java C, and then another one is Java. So here, what are the program which is written by the user that can be compiled with the corresponding the code notation procedure. For example, that is C drive. We are using the command which are using Java C. It is a compiler, and the program name that is first.java program, and the release of dot class file without suppose any errors are there, that is to be displayed. Suppose if there are no errors in the program, then it returns the dot class file. After that, we are going to execute the program. So this execution is Java space file name. So here Java space file name, this is called as interpreter, Java interpreter. It is going to be execute the program. It is called as compiler, Java compiler. Java C is the compiler and Java here is interpreter. So here come two parts, two is doing. First is compilation, second one is interpreter. So that's why compiler, interpreter uses both. That's why this approach is called as hybrid approach. This approach is called as hybrid approach. And then some of the languages which we have seen previously, that is compiled versus compiler languages, C, Java, Fortran, and we have seen the interpreted language PHP, Python also. Individual languages are also following some of the category notations, and some of the programming languages follow this type of notations also, where the getting the output results are to be. What are the diagrams previously which we have used in this one? That is are to be available in the textbook, that is Computer Tools and Techniques Tools, Alfred, Ravi Setu, and Woolman, and three others, Pierce and more. There you can find these diagrams as the reference of this one. So the next session we are going to see the phases of a compilation process. That means how the language processing system has been implemented. The compiler alone can't do the task, so it can divide it can give the job to the different phases of the compilation. That is to be shown to the user how it can be converted internally, each and every phase working mechanism, and later the program is to be converted into object code that is machine understandable, so that the machine directly understand and give the output of the program. So this entire process is to be used for the purpose of compiling your source programming language into the corresponding target program. So why? Because that is the machines can't understand the corresponding programming language, where users can't write the machine language directly. So in order to do the task of the both the cases, a medium or translator is required. So compiler is the one which is doing this job of compilation process, and then understand the program statements what is written by the user easily, and then easily converted into the object program by implementing this phased by manner. 6 phases are there. In the next session, we are going to see what are the 6 phases, how it can be helped together to convert your program into an object. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.